Okay? Now the next time he fires it, I'm going to fall. And the bend of the bullet and how much I fall are going to match, so I get to catch the ball. Now let's say he shoots it faster this next time. If he shoots the bullet really fast, it gets here so quick that I don't fall very far, but it doesn't bend very much. So I just catch it down here a little bit. If he shoots it slow, it takes a long time to get here. I fall a long ways, but it bends a lot, so I catch it down there by the mat. If gravity didn't even work, I wouldn't fall and the ball wouldn't bend. I'd catch it right here. Nothing can go wrong with this demonstration.
Say, Hank, before I shoot the cannon, do you remember the comment you made about my brains coming out of the back of my head? I'd like you to think about that in your life classes. I'm going to arm it.
Yes.
Right? It's armed. Okay, a little help. On the count of 3. 1, 2, 3.
And that's what we call physics. Hi everyone, I'm Mr. Worth. I'm down in room 216, and I made this video so I could introduce some of the great things about physics and try to encourage you to sign up for physics when the sign up comes up next week. Now you may know that next year we're going to offer general physics for the first time in about 3 years, and in addition to Regents Physics, which I teach, I'll be teaching the general physics class. I really want to encourage everyone to take physics, whether it's general, Regents, honors, or AP. It's a fantastic course. It's one of the basic sciences. We learn about a lot of different things. What you just saw was a video produced by the University of Minnesota by their physics department, and what they demonstrated was something called the monkey hunter effect. What this meant was for you to shoot a monkey out of a tree, if that monkey falls at the same time as you shoot your gun, you just simply have to aim at the monkey, and if he drops, you will still hit him. And that's because your bullet, as fast as it's going, will still fall at the same rate as the monkey coming out of the tree. In that case, the monkey was a professor, but he caught the ball, which meant he would have been shot by the hunter. Learning about those sorts of things, which we call projectile motion, is one of the key parts of physics, and that really involves learning about how objects move. That was a demonstration of uniform motion. That little car was traveling at a constant velocity. We'll study how things move, we'll characterize their velocities, accelerations, displacements, and other things. Perhaps you're interested in waves. We play with slinkies. This is an example of what's called a longitudinal wave. This is how sound waves travel, and this is a lot of fun just to play with. I do this a lot just in my spare time. Something else we study is sound waves and something called resonance. Right here I have a tube of a particular length. You can see that it's hollow. If you can hear that louder sound, that's called resonance. The air inside the tube is resonating. It wants to vibrate at that frequency, and it actually amplifies the sound. This is how wind musical instruments work. Going back to the motion of projectiles, we have a set of air rockets that we use, that we take outside and launch down the front lawn, straight up. We figure out how we can hit a target with these objects because we know we can predict their motion after we take some measurements. And we actually aim at targets. Here's a spring. We study springs. We can store energy in springs. We can discover how much force you need to apply to a particular spring to store a certain amount of energy. Here's a spring mass system. Up here we have one of our electronic sensors that will detect the force and capture that data for us. And we can relate the force that's being applied to this spring, which comes from the mass that's hanging and moving up and down. And we can study this system. This is a simple harmonic motion system. Here's another application that we study regarding waves. These tuning forks are connected to a resonance box, which amplifies their sound. Now listen closely when I strike the other tuning fork. Did you hear that science fiction movie sound? Those are called beats. That's a result of interfering sound waves. One wave and another wave of slightly different frequency can produce a third type of wave that we interpret as something called beats. We do a lot of work with electricity. This happens to be what's called a digital voltmeter. It measures electrical current and electrical voltage. We study electrical circuits and how they behave. We work with magnets. This is a great magnet. This thing can pick up your little sister, but don't do that. Here we are, attaching it to the spring. We study magnets, how they behave, and you may know that the Earth acts like a big magnet. That's why compasses work. Here's another magnetic demonstration. You can see these magnets are floating in space. Magnets can actually act as if they're a spring. Flip that over. They're repelling each other, and there actually is enough in there to force them to lift their own weight. We study optics and the paths of light rays. Here's a glass block. We pass some light rays through this, and we try to understand why light bends when it passes through a glass block. Not only do we study current electricity, we study static electricity, which is all around us, especially during the winter like this. I can produce static electricity, which means I'm just grabbing the electrons off of this fur and putting them onto this plastic rod, and I can pick up things with this, because static electricity, of course, has a positive and a negative characteristic, electrons and lack of electrons, and that can produce forces. This is a device called an electroscope that helps us detect the presence of a static charge. I've got a static charge on this plastic rod. If I bring it near this device, you can see that the needle, which is just a foil rod in there, rotating on a needle, will move. I can detect the presence of charge with this device, an electroscope. Right here, you may have seen one of these. It's merely a spring scale. Helps us measure forces. We measure forces in newtons. Won't be able to see the scale, I don't think, but if you take physics, you'll be able to find out what a newton is if you weren't aware in the past. How about collisions? Here's a ball that's going to collide with the tabletop. It bounces. Why does this one do this? This is called the happy and sad ball. This one's the sad ball. It comes into the scene fairly quickly, so it's hard to see, but it just stops. We also study objects that go in circles. Here we go. Watch. Didn't quite make it. Circular motion. Now your teacher's going to give you two separate handouts. One of them is titled 10 Reasons Why No Student Should Go Through High School Without Taking Physics. Please take a look at this and read it. Physics is a basic fundamental science that colleges love. If you have a good grade in a physics class, that says something about you. Even if you're not going into science or physics especially, it doesn't matter. Physics is an important science. The key thing that physics does is teach you how to think. It teaches you how to solve problems. And that's what people hire workers for, to solve problems for them. That's what you get paid for. You don't get paid to do some repetitive job, or at least not very much. You get paid to think and to solve problems for other people. So a successful life and a successful career can start with physics. There's one other handout that I'd like you to take a look at. It's called 7 Myths About High School Physics. It gives you some of the things. For instance, it'll lower your GPA and hurt your chances of getting into college. Absolutely not. Your GPA really doesn't mean a whole lot because it's the individual courses that are the most important. Myth number 2, only mathematically advanced students can take it. Physics. That isn't true at all. We're offering general physics, which has a little bit less math. It's one less class a week. Regents physics, the math is not beyond trigonometry and basic algebra. It's only when you take AP physics where you get into calculus-based physics. Oh, here's another good one. Myth number 4, physics is for boys. Oh, that's terrible. Don't even think about that one. Students who don't need to take physics in high school because they can just take it in college. Not true. If you are taking physics in college, it's a great start to have it in high school. If you're not taking physics in college, then it's an even better reason to take it so that you're introduced to the science and use it to help you solve problems in whatever field you choose later on. Take a look at this information and please consider taking one of the physics classes here at Mendon High School next year. Thanks very much, and I hope to see you in my classroom or in Mr. Peachy's classroom next school year. Thank you.